This is our home planet. Life on Earth does not always come easy. Geysers, eruptions, violent earthquakes, and volcanoes, all threats to human life. But even here, people survive and thrive. The harshest environments force us to struggle, to discover, and to invent. In Iceland, human ingenuity allowed us to settle on this smoking, shifting, angry land.
These are all dangerous volcanoes, and they can do very dangerous things.
They've opened up this huge rift valley because here the plates are directly moving apart from each other.
The crater ejected bombs, ash and pumice over the town.
In Iceland, the volcano's powers increased tenfold because they're capped with glaciers. Eruptions cause ash clouds or powerful floods called jökulhlaup.
This kind of jökulhlaup does not leave anything behind. It's covering everything or washing everything away.
In life, everywhere in the world, anything can happen. You're always, this close to dying anyway.
Humans cannot stop nature's power, but they can fight back. Confronted with extreme conditions for so long, the Icelandic people have taken a lead over the rest of the planet. They have found innovative solutions for dealing with natural hazards. They have also invented revolutionary technologies to take advantage of this unstable land. Everywhere, Iceland's earth bears the scars of its turbulent history. It's the story of a land that sprung up from the depth of the Atlantic when a rift formed in the oceanic tectonic plate. A rift that can be explored by diving down to the heart of where Iceland was born.
We are here in between this rift valley here. On that side we see the North American continental plate, and right behind you there we have the Eurasian continental plate. This is where basically Iceland is born in a way. As the plates have been separating, in this point they've opened up this huge rift valley because here the plates are directly moving apart from each other.
This place is unique in the world, a spot that divers dream of, at least those bold enough to slip between two tectonic plates. The thick diving suit insulates its wearer from the near-freezing water. In this unique place, where the Earth is torn apart, divers can touch two continents at once, the left hand on Europe and the right on America. The water is exceptionally pure and gives the impression that you're floating like an astronaut. It comes from glaciers, then seeps between the fractures in the volcanic basalt. Then it sinks to form a water table 8 kilometers deep and re-emerges here 30 years later, filtered by the volcanic rocks. This fissure that traverses Iceland is the only exposed part of a huge 15,000 kilometer long rift from the north to the South Atlantic. Dotted with underwater volcanoes, the Mid-Atlantic Ridge is the consequence of the tearing of the Earth's crust caused by continental drift. Barely 20 million years ago, magma found a way through the fault and caused the volcanoes that became Iceland to emerge from the ocean. Today, the two halves of the island are still moving unstoppably away from each other by several centimeters per year. Iceland is a young, shifting, unstable land. Quakes happen daily. They are caused by the movement of magma underground. Originating from the bowels of the Earth, magma finds its way through the cracks in the crust to the surface. The ground must be constantly monitored to anticipate the volcano's awakening and protect the population. Bjarki Kardalandsfries is part of a team of scientists on duty around the clock who look for signs of the sudden awakening of one of Iceland's 130 active volcanoes.
So far today there's been around 15 earthquakes in Iceland, and most of them have been all over the country. The blue areas here are all the earthquake stations. So there's around 70 or 72 stations in Iceland. The red one here is just showing the position of the actual earthquake that I was now. It could be anything from 20 to 100 earthquakes in one day. Of course, if you have an eruption, they have much more earthquake activity than you have now. You can't really predict when the eruption is happening, but you can say something about the activity in the area. Of course, you inform people as quickly as possible when you think there's something going on, and it's probably better to inform them before than later.
The time between the first seismic alert and the eruption of a volcano is very variable. Each volcano has its own personality, identified by the volcanologists. The characteristic high silhouette of Hekla stands out at the end of the road. It is one of Iceland's most feared and closely monitored volcanoes. It has a very short fuse. Today, a team of volcanologists from the University of Reykjavik is looking for warning signs of a possible eruption. The team, headed by Paro, measures the incline of the volcano slopes with a laser.
So when the pressure in the volcano increases, this tilt site here is tilted slightly this way. And then when the pressure decreases, which happens in eruptions, the tilt will go the other way. So we can follow the pressure changes in the volcano by doing this. And it's inflating now beyond the maximum level.
As the fill level of the magma pocket under the volcano has exceeded the maximum reached just before the previous eruption, the scientists fear that an eruption is imminent. And the anger of the Hekla volcano is formidable.
You have had really big eruptions both in historical times and also pre-historical times. But just in the back you can also see an eruption from 1845 where you basically had a lava flow coming so close to farms that these people also had to move around. You also have eruption in 1970 where you had a poisonous gas that is stick to the ash that is being deposited. And this was kind of moved 200 kilometers away where it falls down and the sheep gets fluorosis, which basically means that the bones start to grow a lot. So you have had many eruptions that have impacted the environment in different ways.
Each eruption is unique and will threaten the population in a different way.
So it's not the size of the eruption that makes the volcanoes dangerous. It is mainly the style of eruption and also duration. So these are all dangerous volcanoes and they can do very dangerous things. And Hekla is one of those. Generally requires very short time to begin an eruption. The last one in 2000, it took 79 minutes. From the first small earthquake until the eruption was going on. It's like a bomb with a very short fuse.
The devastating effect of this bomb will be magnified further by Iceland's distinct topography. Almost 12% of the territory is covered in glaciers. The biggest of them, Vatnajökull, covers an area larger than the state of Delaware. Like everywhere in the world, glaciers are found where it is cold, at the top of the mountains. But in Iceland, the mountains are volcanoes. The largest active volcanoes are capped by glaciers. And where ice and fire meet, amazing and potentially dangerous phenomena occur, like glacial tidal waves. Oddur Sigurdsson is a glaciologist, and since the 1960s, he has been studying and attempting to anticipate the appearance of Icelandic glacial outburst floods called jökulhlaups.
This entire area that we see in front of us here is formed by these jökulhlaups. These kind of jökulhlaups are caused by volcanic eruptions below the glacier, and those eruptions can melt enormous amounts of ice in a very short time. And this water has to run down to the lowlands, and it usually does so in a huge flood. And they both erode the country and build it up by depositing the sediment. Like you see here for this large area behind us, this is all sediment of the jökulhlaups of Katla. And those jökulhlaups are, during their occurrence, the largest river in the world for a couple of hours. This kind of jökulhlaup does not leave anything behind. It's covering everything or washing everything away. There is no man-made structure that will survive such a jökulhlaup.
Tidal waves have already caused tens of millions of dollars worth of damage to Iceland's infrastructure by sweeping aside bridges and roads. During a glacial outburst flood, the flow rate of the rivers exceeds that of the Amazon, more than 200,000 cubic meters per second.
This glacier is containing a big volcano, one of the most active volcanoes in Iceland. The transfer of energy from the lava into the ice is extremely fast. It is almost instantaneous. They can go up to several 100,000 cubic meters per second. It usually leaves the spot instantaneously, but sometimes it gathers in some volume of water, which will cause the jökulhlaup to be even greater.
It is important for Icelanders to be able to anticipate the formation of these tidal waves as far upstream as possible. So, at the Faculty of Earth Sciences in Reykjavik, volcanologist Magnus Tumi is preparing an expedition to explore a geothermal cauldron right in the middle of the Vatnajökull glacier. Around 30 scientists from various disciplines will explore this geothermal cauldron where ice and fire meet and give birth to destructive tsunamis.
We will drive to here and then to Grímsvötn, which is here. We will do measurements to see what changes have happened in the ice surface because of geothermal activity.
Each year, Magnus Tumi monitors the evolution of the melting glacier above the lava pockets. The formation of new cauldrons under the glacier is clearly visible on aerial photos.
And this will be measured closely. This one is growing. The floods that are happening now are getting problematic. We have to take special care with the volcanoes with the ice on top because of the possible damage and danger they cause to the people. And that's one of the reasons why we need to keep an eye on all these volcanoes. We need to know what's going on.
To get to the scientific expedition's starting point, the team have to cross great plains of volcanic sand. Each square centimeter of Iceland bears the marks of volcanism. The atmosphere is joyful as the scientists meet up at base camp before setting out onto the glacier. The jeeps are packed with crates of high-tech measuring equipment, some belonging to Erik Sturkel, a Norwegian volcanologist who has long been involved in these exploration missions.
Right here, we are measuring two major signals. The most important is what's happening in the magma chamber. We see from the GPS now it's rising up, so it's looking good for the next eruption. People in Iceland, they find it exciting. So people, if an eruption is going on, people are going to it to see it. And so more to understand how the world works, and it's very useful for everyone.
The convoy now sets out onto the glacier. The ice is black. It holds the memory of a recent eruption. The Jeep's huge tires have been deflated for better grip on this mixture of ice and volcanic ash. The scientific team ventures onto the ice cap that seals the crater to scan the glacial cauldron and obtain a 3D image. This lava dome could block the next eruption. If the pressure of the steam in the lava at 1,000 degrees centigrade is too strong, it will give way, suddenly releasing an enormous quantity of water and ash. Sometimes when the weight of the glacier blocks the eruption, the hot water will move under the ice cap and re-emerge at the other end of the glacier. That's what happened in 1996. A tidal wave was triggered 50 kilometers from the eruption, to scientists' great surprise. These phenomena are complex and still poorly understood. It is therefore important to study them to protect Icelanders. The 3D scan will enable them to model the cauldron and simulate its activity in the laboratory. Icelanders have learned to come to terms with forces that are impossible to control. Bridges are designed to resist tidal waves thanks to foundations dug 20 meters deep. They are surrounded by dikes that deflect the huge wave rather than try to stop it. In this way, the only road around the south of the island can be protected. Melting glaciers feed the many Icelandic rivers and waterfalls. The slopes are steep. The energy potential of the rivers is huge. The torrents of water coming from the glaciers make it possible to drive turbines and produce electricity. "70% of the electricity produced is hydroelectric in origin, with the other 30% being geothermal. The Icelandic nation still imports fossil fuels for vehicles, but is aiming for energy independence in under 20 years thanks to alternative fuels. Icelanders have also had to innovate to cope with avalanches. From the 1970s, this has been the main cause of death linked with natural events. In the northwest, the oldest part of the island, the landscape has been carved by glaciers that have now disappeared. This fjord configuration is very conducive to destructive avalanches. The inhabitants have found innovative strategies to live with this threat close to villages. The villages are built at the very foot of the walls despite the danger. The coastal strip is narrow and avalanches would fall directly onto the houses. But fishermen and their families had little choice when they chose a space to build. Harpa Grimsdottir is a glaciologist. Since the tragedy in 1995, her village has been protected by an enormous avalanche dike.
This is a deflecting dam that is built to deflect avalanches that come from this big gully up there, deflected out of the way of the settlement and down to the sea. In the year 1995, we had a huge avalanche and it destroyed part of the town. The left side that we see down there, where we have green area now and the small houses, and there were 20 people killed in their houses at that time. So it was decided after that to create a new method of hazard mapping in Iceland. And this is a good way to protect against avalanches because it's easier to deflect an avalanche in full speed out of the way rather than trying to stop them completely. Top part of these mountains are usually about 40–45 degrees steep. And this is a steepness that is very favorable for avalanches, for dry slab avalanches.
This deflection dike, one of the longest in the world, has shown its effectiveness many times over. Several massive avalanches have been redirected without affecting the village. This protective device must be supplemented by constant monitoring of the snowpack. The coastline of this part of Iceland is warmed by the Gulf Stream. The glaciers and snowpack are close to their melting point. The thermal equilibrium is fragile, and snow can suddenly hurtle down the steep slopes of the fjords. It is therefore necessary to regularly analyze the snowpack.
So we are doing this snow pit here to estimate the layers of the snow, if we have any weak layers in the snow, how much new snow we have on top of the older snow that is stable. Wet snow can result in wet avalanches. And wet avalanches, usually they travel a little bit slower. They don't have as high speed as the dry snow avalanches. The destructive power can be great because they are so dense and heavy.
This village benefits from a new system of protection against avalanches. There wasn't enough room to divert an avalanche to the side of the village. So an impressive wall was built, 2 kilometers long, that could halt a future avalanche in its path. Since the arrival of the first Norwegian settlers in the 10th century, Iceland's inhabitants have been confronted by deadly volcanic eruptions. Though they deal with it calmly, this permanent threat is engraved into the collective memory of the 330,000 Icelanders. Everyone here knows the date that Laki erupted. In 1873, 10,000 Icelanders perished following one of the largest eruptions in human history. In 2 days, the eruption pumped out as much sulfur dioxide as European industry does today in 1 year. In Iceland, many villages are built at the foot of volcanoes, which increases the danger presented by eruptions, as was the case in 1973 on the Westman Islands, a few kilometers from the Icelandic coast. Icelanders have a fascinating ability to face dangers that would scare most people away. We see in them human beings' finest qualities, their ability to invent technologies that deal with the forces of nature. Sometimes humans seem motivated by difficulties and find ways to take advantage of the forces of nature. In fact, here in Heimaey, an incredible confrontation between volcanoes and humans took place. And among those who conquered the Heimaey volcano was Sveinberg Björnsson, fighting to save his home island.
This harbor here and the island are very important to Iceland because the harbor here is the only one that we have off the south coast of Iceland. If you had lost that, we would have lost tremendously in our fishing industry. So that's why we put such tremendous effort in defending it and succeeded.
In 1973, the island of Heimaey suffered a massive volcanic eruption. For 5 months, the volcano that makes up the island belched out ash and lava flows, threatening the village and its 5,300 inhabitants. Faced with this danger, they found new solutions to stop the flow of lava.
As you see here, this mountain called Helgafell, or Holy Mountain, and it had been sleeping for 5,000 years and no one was expecting it to come erupting again. But then suddenly on the edge of town, there came up a volcanic fissure and created the other one here on the left. And the hill that you see coming from the mountain down here to the harbor, that is the new lava flow that came in 1973.
During the night of January 22nd, the island's earth was ripped apart. Lava fountains gushed out near homes, with the crack quickly reaching 300 meters in length. The island's population was evacuated, and a group of 250 volunteers, including Sveinbjörn, chose to stay and defend the village and the fishing port. But fighting the volcano was to prove far more difficult than they thought.
We are actually walking now along the fissure that opened in the beginning. The fissure extended at first all the way from the sea down here to the sea on the other side. And there were lava fountains for the first night and first day on the whole fissure. But then the activity gradually concentrated on this spot here, where the main crater was then built up. And the crater then did not issue much lava in the beginning, but it ejected bombs and threw ash and pumice over the town. These were the problems in the first 2 weeks that we had to deal with.
The new volcano literally bombarded the village at its base. Lava bombs started fires, and the houses were buried under a carpet of burning ash. Then suddenly, on February 19th, the danger changed shape. The new volcano, dubbed the Mountain of Fire, released a lava flow that soon grew to be 100 meters thick. The flow entered the village, threatening their precious port. Sveinbjörn and his physicist colleagues proposed a solution that seemed crazy: to spray the lava flow with water to cool the edges and create a wall of solidified lava. The process was a success thanks to pump boats from the European continent. The lava flow was stopped a few dozen meters from the harbor. The team's lava cooling idea came from observing a volcano rise from the sea south of Heimaey. The Icelandic scientists had noticed that on the shores of the new island, the lava flows were solidified when they came into contact with seawater. Nature had inspired the idea of lava cooling. And from observing the process, another idea was born.
People here in the Westmanlands also realized that this was a way of producing steam, and why not take use of it? We estimated that in the lava cooling here, they generated enough heat to heat the town for 45 years. But it took about 5 years to find the best method of exploitation. And then it ran for 10 years. We said that we were taking revenge on the lava.
Heimaey is an open-air laboratory when it comes to understanding the types of danger represented by a volcanic eruption close to houses. The perils associated with an eruption are multiple: lava flows, volcanic bombs, ash clouds. They can all come from the same volcano during a single eruption. This lava cooling project remains a textbook case for volcanologists all over the world. Not only did humans manage to contain a natural, destructive force, but the fight to do so stimulated the Icelandic geothermal industry. For centuries, Icelanders have had the idea that the fire that lies beneath their land could be used for something. The hot water in rivers at over 40 degrees centigrade allowed the first Viking settlers to bathe in steaming pools, the ancestor of the jacuzzi. Today, Icelanders keep the tradition alive and come on Sundays as a family to splash around in the mountain rivers. When the underground pressure is high, hot water emerges from the ground, propelled by water vapor. It's called a geyser. This is the most famous amongst them, Geyser, the one that gave its name to every geyser in the world. A geyser works in 3 stages. First, water accumulates in an underground chamber near the magma. The water heats and expands, but it is trapped in the chamber. The pressure increases, and as a result, the boiling point of the water rises. The water remains liquid even at 150 degrees centigrade because of the pressure. The temperature continues to build, and a bubble of steam eventually forms at the bottom of the chamber. The steam propels the water, which is forced out at the surface, and in turn abruptly lowers the pressure in the chamber. The water hotter than 100 degrees centigrade now suddenly boils. Though the thermal energy of the geysers has not yet been harnessed, the hot groundwater has many uses. The Herargadi region supplies the rest of Iceland with fruit, vegetables, and flowers by using the very specific farming techniques that Guðríður Helgadóttir teaches at the State Horticultural School.
You see the pipe that goes up there? This is the pipe that goes directly to the borehole, into the ground. And the hole that goes into the ground is 0.5 kilometer deep. One part of the steam goes with that pipe into the school building. And the other part goes down to the greenhouses. We use the steam to heat up the greenhouses, where we produce, for example, bananas and tomatoes and all the other plants.
Iceland's acidic volcanic soil and its harsh climate don't allow agriculture outdoors. Yet Icelanders supply 50% of their needs in vegetables and are even autonomous when it comes to salads and certain fruits, thanks to greenhouse agriculture. These practices are taught here at the State Horticultural School. Trees are very rare in Iceland. The greenhouse has enabled this precious rainforest to exist for 70 years. The visit is a unique chance for Icelandic children to discover what is for them an unfamiliar environment, a jungle and its inhabitants. The school has 12 geothermal greenhouses, and for each, the heating, humidity, and artificial light parameters must be precisely adjusted according to the plant you wish to grow. Surprisingly, bananas possess the qualities needed to be grown in Iceland.
If we are producing tomatoes and cucumbers in greenhouses, we have to have artificial lights in the greenhouses because the plants need high light intensity. But during the winter, for example, the shortest day of winter is only like 5 hours on the 21st or 22nd of December. There's hardly any light at all. But the bananas don't care. They just grow very, very, very slowly. The dangers of geothermal energy is that it's maybe not stable every time. Every now and then we have earthquakes in Iceland. It has happened that during an earthquake we lost our heating system. That's actually quite a big disadvantage.
Whenever there are earthquakes, which is often, cracks appear, each creating new paths for the steam to take. In 2008, a geyser suddenly appeared in the garden of Guðrún Eva Minorvudóttir's neighbor. Since then, he has built this geothermal greenhouse that supplies fruit and vegetables to the whole neighborhood. Guðrún and her daughter Minerva benefit from this until the next earthquake.
But you know, the area beside my garden is you can't build on that because it's the ground is warm. And before I moved here, a few years before I moved here, there was steam coming from there.
Even though they have built cozy homes, one wonders why the Icelanders cling to their angry land.
You know, I often think about this. Like, this island could literally just explode. But it's like we are used to it, and nobody really thinks about it. Anyway, in life, everywhere in the world, anything can happen. You're always, you know, this close to dying anyway.
The unstable Icelandic ground provides opportunities for those who know how to tame it. Icelanders seem to draw their life force from danger, just as they draw energy from the subsurface to feed their greenhouses and geothermal power plants. It's a worldview that is perfectly adapted to the harsh Icelandic conditions. Since the 1960s, Albert Albertsson has been a pioneer of geothermal energy. He now heads a veritable empire based on the exploitation of Icelandic natural resources. He sees everything offered by nature as a potential godsend.
I love the earthquakes. They keep the earth open for the flow down there to circulate around and pick up the heat from the rock. So the earthquakes make our resource a renewable one. Actually, it is fueling our life. This tie is made by Indians in North America. They were spiritually connected to the nature. And unfortunately, we have lost this connection. And for example, when the Indians, they shoot their prey, they used every single piece of it. Therefore, one of the main goals of the resource park concept is society without waste. There is no waste, there is only resources to be used.
One of the best examples of visionary entrepreneur Albert Albertsson's philosophy, both effective and extremely lucrative, is the Blue Lagoon, one of Iceland's icons. It all started in the 1960s. One of Albert's power plants discharged water into nearby volcanic rock pools. Saturated with silicate, the released fluid has a vibrant color. It is hot, and the locals are used to bathing in these lagoons. They find that this turquoise water heals skin complaints such as psoriasis. 40 years later, a spa complex was built, and each year attracts 1.5 million visitors from all over the world. They come here to bathe and follow a silicate-based course of treatment costing over €100 per day. Thanks to the Blue Lagoon, the power plant discharge brings in much more than the power plant itself. A fine lesson in optimizing resources. Around his first plant, Albert Albertsson has gradually created a geothermal Silicon Valley resource park. Here we find startups that use geothermal energy or its derivatives. The Icelandic plains are covered by numerous pipelines. They carry the precious geothermal fluid to the power plants, releasing mainly water vapor and a small percentage of CO2. Geothermal energy supplies 30% of the country's energy needs and also provides heating for the main cities. A geothermal plant produces electricity and hot water from geothermal fluid, a mixture of gases, minerals, and pressurized water. Wells are drilled to a depth of 2 kilometers where the water table is close to hot volcanic rocks. Then, as in a geyser, the pressure of the geothermal fluid reduces as it rises in the pipeline. It's still under considerable pressure when it arrives at the surface, where it must also be stripped of minerals which can corrode pipes. On the one hand, the warmth is recovered for heating, and on the other, the pressurized water vapor drives a turbine. It produces electricity like the dynamo on a bicycle. After a few years, the water table is emptied and its exploitation must stop until it is refilled by rainwater and seawater. And give geothermal energy a bigger profile. Iceland is already contributing to the reduction of CO2 emissions through the use of renewable energies. But Icelandic scientists want to go further and clean up our atmosphere. They have developed a process called CarbFix, which enables CO2 to be trapped underground over long time scales.
CO2 emissions are just a byproduct of geothermal energy production, and now we have stopped emitting all the CO2 into the atmosphere. So what we're doing is that we are reacting CO2, dissolved CO2, with basalts to form these stones here. And once the CO2 is turned into stone through this process, I mean, it stays like stone for millions of years. So it's a permanent way of fighting climate change.
Methods of injecting CO2 into underground chambers have already been tested elsewhere without success. CarbFix, the Icelandic method, is totally safe. The CO2 is petrified in just a few years. Sigurdur Reynir Gislason at the Reykjavik Institute of Earth Sciences is one of the inventors of the process. He is looking to optimize it for large-scale use. In this titanium tube lies part of the solution to reduce the greenhouse effect that seems to be disrupting our planet's climate.
What we're doing here is we're trying to mimic what's happening at the CarbFix site at Hellisheiði, east of Reykjavik. And what we have here, we have a titanium column, and then there's a syringe pump that pumps liquid CO2, and this column is stacked with basaltic glass. As soon as the water starts to percolate and react with the basalts, the CO2 charged water attacks the rocks and releases calcium, magnesium, and iron. This is the beauty of it. We form a solid, stable, and this is the most stable form of carbon, in the Earth. About half of it is CO2 in this mineral. This equals, in terms of CO2, the volume 75 liters. It's one of this tank, one of that one, and another one of this. We could take all the CO2 and it will fit into this mineral.
Motivated by an environment of limited resources, Icelanders have found solutions to render industrial byproducts harmless or even transform them into wealth. Nature inspires our technological creativity, but also our artistic creativity, as shown by Harpa, the Reykjavik Cultural Center, or Hallgrim's Church, inspired by Iceland's basaltic columns and glaciers. There's no doubt that when they pray, Icelanders converse with the forces of nature without fear. The Icelandic people have been able to adapt to the raging and rumbling of their extreme land. Iceland could export, in addition to its green electricity, solutions for living in harmony with nature that its inhabitants have developed. Like this, we could reduce the negative impact of industrial society on our fragile Earth.